Right, in the previous section, we factored using the distributive property, and we found that if we're going to use the distributive property with a polynomial to get two separate factors, we had to have 4 terms. But here we're going to look at a quadratic in the form of x squared plus bx plus c. Notice the leading coefficient is 1. So today, all of the problems that we're going to look at have a leading coefficient of 1. But before we look at how to factor, let's go back and look one more time at how we would multiply these binomials. Using FOIL, we have the first terms we multiply together, so we get x squared. The outside terms, which would give us 4 times x. The inside terms, which would give us 2 times x. And the last terms, 2 times 4 is 8. And if I simplify, I get x squared plus 6x plus 8. And this is in the form, standard form of a quadratic, which is ax squared plus bx plus c. Now notice here that b is the sum of the last term of each binomial. Now this is the case when that leading coefficient is 1. So we're going to look at some ways that we can figure out if we're given a trinomial, if we're given a quadratic, how we can factor. And there are some things that we need to think about, that we need to understand, that if c is positive, then the factors have the same sign. All right, if c is positive, the factors have the same sign. They could notice in the one that we did, we had x plus 2 times x plus 4, and c was positive. If we did x minus 2 times x minus 4, well, when we multiply that out, we get x squared minus 2x minus 4x, did those backwards, plus 8. So it's possible that if c is positive, both factors could be negative. So if c is positive, the factors have the same sign. They can either both be positive or they can both be negative. Okay, in a few minutes, we'll look at what happens if c is negative. If c is negative, then the factors are different. One will be positive and one will be negative. But we'll look at that again in just a few minutes as we get to one where c is negative. So let's look at an example of how we can factor a quadratic. I think many of you probably have done this in the past. I know you've had exercises. If you had Miss Anderson last year, you had some quizzes where you were practicing for this very thing. Now let's look at x squared plus 9x plus 20. In the previous examples that we looked at, if we look here, notice 2 times 4 was 8, but 2 plus 4 is 6. So we need factors of 20 that will multiply to be 20, and when we add them together, they need to be 9. So factors of 20, we know that we've got, and since this is positive, both terms are positive, so we're going to have an x plus and an x plus. Now, if we find factors of 20, we have 1 and 20, 2 and 10, and 4 and 5. And if the sum of those factors, here's 21, 12, and 9. So this is what we want, x plus 4 and x plus 5. In this case, since both have the same sign, it doesn't matter which order you put them. You could put x plus 5 times x plus 4. So let's look at some more examples of this. All right, I have the quadratic x squared plus 7x plus 12. So we're going to look at factors of 12. I'll just put a multiplication and then see what their sum is. So you might see immediately, but let's list all the factors. We have 1 and 12, and the sum is 13. We have 2 and 6, the sum is 8. We have 3 and 4, and the sum is 7, and that is the sum that we're looking for. So this becomes x plus 3 times x plus 4, and again, it doesn't matter whether you say x plus 4, x plus 3, because they're both positive. It doesn't matter about the order. All right, let's look at another one. D squared plus 11d plus 24. Okay, so what I'm going to have to find is factors of 24 that when I add them together, their sum is 11. So factors of 24, 1 and 24, that's not going to work. Sum's 25. 2 and 12, that's not going to work because that sum is 14. 3 and 8, well, 3 and 8 is 11. So I found the combination that I need, and this becomes d plus 3 times d plus 8. And again, order does not matter. Okay, this one is written in a little bit different form. Remember, we said in the form ax squared plus bx plus c. And since this is a plus t squared at the end, let's just rewrite this so that it's in that form that we're used to seeing. T squared plus 10t plus 9. And I think it will be easier for us to factor that way. All right, so we need the factors of 9 that will add up to 10. So if we have 1 and 9, well, that's 10, and we're done. So we would have t plus 1 times t plus 9. Again, if it's written this way, I would suggest that you rewrite it so that your squared term is first, and then it's a little bit easier to see how that factors. Now, with all of these, both of the binomial factors were plus, but let's look at what happens if our quadratic is x squared minus 12x plus 27. Okay, remember what I said. If this is plus, then both factors are the same. So we're going to have an x minus and an x minus. So let's think of factors of 27. All right, if we have factors of 27 that add to give me 12, well, we could look at -1 and -27. Remember, they both have to be negative, but when I add them together, if I multiply them, I get a positive, but when I add, I get a -28. We could use -3 and -9. Well, -3 plus -9 is -12. That's what I want. So we have x minus 3 and x minus 9. Since this was positive and this was negative, these are both negative. Okay, let's look at another one. Okay, w squared minus 11w plus 28. Again, it's going to be a w minus and a w minus. because the last term is positive and the middle term is negative. All right, so we're going to have to find factors of 28 that when I add them together give me a negative 11. So we could do negative 1 and negative 28. And that gives me negative 29. That won't work. If we did negative 2 and negative 14, if I add those, I get a negative 16. What about negative 4, and negative 7? Well, if I add those together, I do get a negative 11. So we can use W minus 4 and W minus 7. All right, let's look at one more. 21 minus 22m plus m squared. Again, I don't like having that m squared at the end, so I'm just going to rewrite it. I'm going to let the m squared and the 21 switch places. M squared minus 22m plus 21. Notice there's no sign here, but that means it's positive. So I need factors of 21 that when I add them together give me negative 22. So we could use negative 1 and negative 21, and that does give me negative 22. And I am already finished. We'll have m minus 1 and m minus 21. And we have that factored. Oops. Okay, we're going to look at some that are a little bit different. This time, C is going to be, if C is negative, then the factors have opposite signs. Okay, if C is negative, its factors have opposite signs. The factors have opposite signs. To determine which factor is positive and which is negative, look at the sign of B. The factor with the greater absolute value has the same sign as B. All right, so we'll just look at some and see how that works out for us. Okay, let's look at x squared plus 2x minus 15. All right, so we're going to have opposite signs. And the larger, since this is a plus, the larger factor is going to have the positive. So let's look at some factors of 15 that when I add them together would give me 2, or factors of negative 15 that when I add them together would give me 2. All right, well, we could try negative 1 and 15, and that's not going to work. That gives me 14. The next thing that goes into 15 is 3, so we could try negative 3 and 5, and when I add those together, I get 2. Notice I knew to make the 3 negative because we had a positive. I needed the absolute value of the smaller number to be positive. I hope that made sense. So we're going to have x minus 3 times x plus 5. And you can always check if you're not sure that you did it correctly. Let's FOIL this. X times x is x squared plus 5x minus 3x minus 15, and that gives me x squared plus 2x minus 15. So that was done correctly. All right, let's look at another example. X squared minus 7x minus 18. All right, this is a negative. Now, I'm not saying this mathematically correct, but I know you'll understand what I mean. The larger number is going to have the negative with it, the larger factor. All right, so I need factors of negative 18 that would combine to give me, that would add to give me a negative 7. So if we think of factors of negative 18, we could try 1 and negative 18. Well, that gives me negative 17. I could try 2 and negative 9. And when I add those, I get negative 7. So we have x plus 2 times x minus 9, and we have factored. We've already got as far as we go. We could go ahead and look at 3 and negative 6, but we've already found out what we need, so we don't have to go any further. Okay, so let's look at y squared plus 13y minus 48. Okay, so we're going to need factors of negative 48 that when I add them together give me 13. So if we think of factors of negative 48, we could do a negative 1 and 48. Well, that's not going to work. We could do negative 2 and 24. Well, that gives me 22. That won't work. We could do negative 3 and 16. Well, negative 3 plus 16 is 13. So we have y minus 3 times y plus 16. Okay, hopefully you're beginning to see that this is not a real difficult thing to do if you will just be systematic in checking your factors. Let's do one more like this. R squared minus 2r minus 24. Okay, so hopefully you see that the larger number is going to have the negative. Not the correct mathematical way to say it, but I think it's the way that you will understand it. So we need our factors of negative 24 that will add up to give me negative 2. So we could use 1 and negative 24. Well, that gives me negative 23. That won't work. We could use 2 and negative 12. That gives negative 10. That won't work. We could use 3 and negative 8. Well, 3 and negative 8 gives me negative 5. We could use 4 and negative 6. That gives me negative 2. Notice I'm starting with the smallest factors that will go into the number so I don't skip anything. Okay, so we're going to have r plus 4 times r minus 6. And that is how this one is factored. Okay, now none of the previous examples that we worked were equations, but this is an equation. It's a quadratic equation, which means there are two solutions because it's a quadratic equation. And in this case, we need to factor it in order to solve. You can't just find x equal the way the problem is right now. So in order to, before we can factor, we have to get it into that form, x squared plus bx plus c, or it could be minus c, whatever. But anyway, we have to get it into this form equals 0. We have to set it equal to 0. Remember, we had some problems similar to this in the last section, except they were already factored for you. So let's look. X squared plus 6x minus 27 equals 0. All right, just like we did before, by now you may be getting the hang of it where it's not always necessary for you to list all the factors. You may see which way it needs to go. But we're going to have the larger factor be a positive. So we think about 27, negative 1 and 27. And you may not even need to write that one down. And 2 doesn't go into it. 3 goes into 27, so negative 3 and 9. And when I add those, it gets me 6. So we've got our factors x minus 3, x plus 9 equals 0. And remember that either x minus 3 equals 0 or x plus 9 equals 0. So we can add 3, and x is 3, or subtract 9, and x is negative 9. So these are the two solutions. X is 3, or x is negative 9. Let's look at another one. Okay, again, we're going to have to subtract 70 from both sides, so I have it in the form that I need it to be in. X squared plus bx plus c equals 0. We're not paying attention in this example. That doesn't matter about the signs. I just need it in that form. So we'll have z squared minus 3z minus 70 equals 0. All right. This time the larger number is going to have the negative. Okay, 1 and 70 is not going to work. We know that won't work. 2 and 35, negative 2 and 35 is not going to give me what I need. Let's skip to 7 and negative 10. If I add those together, I get a negative 3. So our factors are z plus 7 and z minus 10 equals 0. So either z plus 7 equals 0 or z minus 10 equals 0. If we subtract 7 from both sides, z equals negative 7, or we can add 10 to both sides, and z equals 10. So we have solved this. If you're not sure, go back and plug it into the original equation and see if you get a true statement. Or plug it into the factored form. Negative 7 plus 7 is 0, and 0 times anything is 0. Or if you plug in the 10, 10 minus 10 is 0. If we plugged it back in to the original equation, negative 7 squared is 49. And negative 3 times negative 7 is plus 21. 1 and 9 is, and let's see if that equals 70. 1 and 9 is 10. 5 and 2 is 7. So that works. Negative 7 works. You could do the same thing with 10. 100 minus 30 equals 70, and that's true as well. So those are correct solutions. Okay, I think I've given you enough examples to see how we factor quadratics that are in the form x squared plus bx plus c. In other words, the leading coefficient, the coefficient of the squared term is 1, right? So your next assignment is assignment number 13. And that will be on page 507. And I want you to do 2 to 28 even.